Half a mile offshore in the Bahamas, 600 tons of flat rectangular stone blocks line the ocean floor in a perfect J-shape, and no one can agree whether humans put them there. By the end of this video, you will understand why this 1/2 mile of rock has split geologists, archaeologists, and oceanographers into two irreconcilable camps for over 50 years. The most jaw-dropping detail is not the size of the stones but their shape. These are not boulders, they are flat-topped rectangular slabs, some measuring up to 15 feet across, fitted edge to edge like a paved road. But here is the thing almost nobody realizes: the Bimini Road was predicted, in writing, 28 years before a pilot spotted it from the air in 1968. In 1940, the psychic Edgar Cayce claimed that ruins of Atlantis would rise near Bimini around the year 1968 or 1969, and then a pilot named Robert Brush spotted the formation in September 1968. That coincidence electrified the world, and suddenly every documentary crew, treasure hunter, and amateur archaeologist was diving on what people were calling the Lost Highway to Atlantis. The formation sits in just 15 to 20 feet of water, shallow enough that you can snorkel over it on a clear day and see every stone in perfect detail from the surface. The road stretches roughly half a mile, curves gently at one end, and the largest stones weigh an estimated 15 tons each, which raises the obvious and urgent question: what force on earth lined them up this neatly? The geological explanation centers on a process called beach rock formation, limestone that hardens inside tidal zones when calcium carbonate cements loose grains together, layer by layer, over centuries. Beach rock always forms in horizontal sheets parallel to the beach, and when those sheets fracture, which they do, along predictable joint patterns, they break into rectangular blocks. Geologist Eugene Shin, who sampled the Bimini blocks in the 1970s, found that the rock layers and adjacent stones continue seamlessly across the joints, exactly what you expect if the blocks formed in place and never moved. He also found micrite and pelloids, microscopic sediment structures that only form in shallow tidal environments, ruling out the idea that these stones were quarried inland and dragged to the sea. Radiocarbon dating of shells cemented inside the blocks returned ages of roughly 2 to 3,500 years, not 12,000 years, nowhere close to the end of the last ice age. So the geology team's verdict was firm: natural beach rock, formed in place, fractured into rectangles by ordinary tidal stress, then submerged when sea level rose over the past few thousand years. But here is where it gets genuinely strange, because the archaeologists looked at the same stones and found details the geologists had not fully accounted for. Marine archaeologist Manson Valentine, one of the first scientists on the site, noted that some of the largest stones appear to rest on top of smaller prop stones, a three-point support system that does not appear in natural beach rock anywhere else. If those prop stones are real load-bearing supports and not just random rubble that drifted underneath, they suggest something placed the large stones deliberately, because nature does not build three-legged tables. A second anomaly: the blocks at the northern end of the road curve inward at both sides, forming what looks like a double row, a detail that critics say would require two parallel beach rock shelves forming simultaneously at identical depths. Researcher Dmitry Rybakov used an underwater sled camera in 1969 and mapped an additional section extending further northeast, suggesting the structure may be significantly longer than what the 1968 pilot first saw. Then in 2006, researcher William Donato announced that side-scan sonar revealed what appeared to be a second, deeper formation running parallel to the first, roughly 100 feet to the east and 20 feet lower. If that second formation holds up under direct excavation, it nearly doubles the scale of the site and makes the single fracturing shelf explanation far harder to defend. And here is the mid-story cliffhanger you have been building toward. 12,000 years ago, during the last ice age, this entire area was dry land, a low limestone plain sitting well above sea level. As the glaciers melted between 15,000 and 7,000 years ago, global sea level rose by roughly 400 feet, and the Bahamas bank, which is enormous and nearly flat, would have flooded gradually over millennia. That means early humans, the ancestors of cultures who built the first permanent settlements, were walking on this limestone plain at exactly the time Bimini was still above water. The critical question the whole debate hinges on is whether those prop stones are real structural supports, and frustratingly, no excavation has yet been permitted to dig beneath the largest blocks to settle it definitively. The Bahamian government regulates underwater archaeological access strictly, and every proposal to properly excavate has run into permitting delays, funding gaps, or scientific disagreement about methodology. What we do have is a 2011 study in the Journal of Marine Archaeology that used quantitative image analysis on the prop stone geometry and concluded the support configuration was statistically unlikely to be random, not impossible, but unlikely. The honest scientific position today is this: the bulk of the physical evidence, the rock chemistry, the carbon dates, the fracture patterns, supports natural beach rock, but 2 or 3 anomalies remain genuinely unexplained. Compare this to Yonaguni in Japan, another underwater stone formation that sparks identical debates, where geologists and archaeologists have been arguing for 3 decades without resolution, because the ambiguity is the same. Nature, it turns out, is a far better architect than we give her credit for. She can produce right angles, flat surfaces, and parallel rows without any human assistance, given the right rock type and enough time. But the ocean floor also hides far more ancient coastlines than we have yet surveyed. Only roughly 20% of the global ocean floor has been mapped at high resolution, meaning most of prehistoric humanity's coastal settlements are still down there, unseen. The sea level rise that swallowed Bimini also swallowed settlements in the Persian Gulf, the North Sea, the Sunda Shelf in Southeast Asia, and the continental shelf off India, and in several of those locations, we have already found undeniably human structures beneath the waves. Off the coast of India at Dwarka, divers found stone anchors, pottery, and structural walls dated to roughly 9,000 years ago, genuine human construction, submerged by the same post-glacial flood that may have touched Bimini. That broader pattern, drowned coastlines hiding lost chapters of human prehistory, is now a serious and growing field called maritime archaeology of submerged landscapes, and Bimini sits squarely in its crosshairs. So what will it take to finally close the debate on Bimini, to look under those 15-ton slabs and either find deliberate foundations or prove once and for all that nature did it alone? It will take one properly funded, properly permitted excavation, something marine science has managed at far deeper and more difficult sites than 15 feet of warm Bahamian water. And now pull back from the limestone and the dating charts and feel what this question is really asking, because under that warm shallow water is a moment when the world your ancestors knew was being erased by rising seas, forever. Every human culture on Earth carries flood myths: Mesopotamia, India, the Americas, Polynesia, and the reason may not be metaphor. 12,000 years ago, the seas really did swallow entire worlds in living memory. Whether the Bimini Road is natural or human-made, it is sitting exactly where a coastline used to be, and the people who once stood on that shore, watching the water inch higher each generation, felt the same bewilderment you would feel today. The ocean does not forget, it just keeps the file sealed in salt water and silence, waiting for the day we build the tools and find the will to finally open it. Follow Science Explained daily for more.